Hello, we are still working on Chapter 4, Section 1, Graphing Relationships. We're looking at example number 3 from the book, which is where we are going to have a graph and we're going to write a situation about the graph. And I always have, we spend a little bit of time with this in class because I want to really talk about the fact that I don't need detailed, like long drawn out explanations. I just need enough so that you can show me that you understand what's going on here. All right. So I don't need you to actually write a book or anything. We're just going to describe what you're seeing from the graph. Now this goes back to like our first problems where we were connecting the words with the graphs. And then in the last video, let me get to that page. In the last video where we had the words, but then we drew the graph. Now we have the graph and we need to come up with the words. So we're going to cover all the bases. All right. So let's look at what this is. First of all, the variables here, I have time versus water level. Now, what do they mean by water level? Well, that's like how high the water is. Well, where is the water? Well, the water could be in a lake. It could be in a bucket. It could be in someone's yard. If you've got like water problems in your yard. All right. Could be in your cup if you're there's my Yeti. Okay, I'm drinking some water right now. The water level just went down. All right. So you have some, since the graph doesn't say anything like that, you have some flexibility for how you want to say that. But I don't need it to be too complicated. Okay. So it doesn't matter. We can say like maybe in a lake because we do live in Minnesota. So let's talk about the lake. All right. So, and also I don't have a scale here. I know I want to say that that's 0, but it doesn't have to be 0. It could just be wherever I start. All right. Not all graphs have to start at 0. We'll talk about when we want the graphs to start at 0 as we go further with this. So let's kind of describe what's happening here. Okay. So this red part is increasing, and remember, time is always going this direction. Time is always increasing. So as time increases, as I go to the right, I'm also going up. So it looks like the water level is rising. So we say at first, the water level in the lake rises, I don't know, significantly. That's a fancy word. You can just say it increases rapidly. It goes up a lot because it looks like it's really steep there. It's not like I don't have anything else. It's not like it would be looking like this where it's going up, but it's really not so steep. Okay. This part right here, the blue part, is where it doesn't go up or down. So then the water level stays constant. And then finally, this green part, the level decreases, I'll say rapidly this time. I didn't like saying significantly, I'll say rapidly. But I'm not even too worried about those adverbs. It's okay. I just want you to know that the water level goes up, stays the same, and the water level comes down. How much it goes up by over time, that's in chapter 5, my friends. We will get to that, okay? So that's all you'd have to do to describe that. Water level goes up, stays the same, water level comes down. Now let's look at this other problem. So I have number of students, maybe the students in a club or a sport or whatever, or a class. And over here we got, if you can see it, says number of pizzas that you're going to buy, right? So what it looks like to me is that if this is 1, 2, 3, or 4 students, you're only going to buy 1 pizza. So 1 pizza is going to feed up to four students. But now that I got 5, 6, 7, or 8 people, now you're going to go and you're going to buy 2 pizzas. Now notice you can't have part of a student. That doesn't make sense. You can't have like 2.3 students. That'd be like an arm and part of part of a leg or something. And also, you're not going to buy part of a pizza. So this is where all of this right here is going to be discrete. To go back to the other problem, time, like I mentioned, is always continuous. That's why there's no breaks between these. But here we just have the points. I'm trying very careful not to call them dots. I know you want to call them dots. So what happens here? Okay, so we can say for 1 to 4 students, only buy 1 pizza. For 5 to 8 students, buy 2 pizzas. And that's all you're doing, describing those. Okay, I'm going to come back with the problem 7, 8, and 9 from the guided practice.